Hi, this is Margo. This is Saturday, July 28th, 2018, and this is my weekly ClimateCast update. And I'm going to start with saying power to the truth, because we're here searching for the truth, whatever it is. And this is the one thing we all do have in common. We all want to know the truth. And in case I get cut off, my name is Margo. My website is margoshealingcorner.com, and I'm a hypnotist, holistic life coach, empathic spiritual healer. If anyone wants to contact me, the best way is just go to my website and hit the contact button and fill out the form and submit. I'm also on Facebook, but I prefer just getting emails, but I am on Facebook as well. Not thrilled about being on Facebook. It eats up time, but it's a real good resource, and I've made a lot of friends over there, and I get a lot of really good information from over there. So the first thing we're going to cover is the sea ice. We're going to look at Arctic and Antarctic sea ice, and then we're going to go to CAMS, and we'll wrap it up for today. And if you missed the Campfire Chats on Thursday, it was a great show. Robin Westenra joined me, and we carried the whole show practically, and he had to sign off and before the end, but he's from New Zealand and just has a wealth of information. So thank you, Robin, for hanging with me as long as you did. We had a great discussion. So we're going to start out with Climate Reanalyzer. This is the sea ice and snow cover page for Saturday, and you can see a marked decline. It's a marked decline since our last show last week. Let me pull up. I thought I would have this ready. I thought I had everything ready, but I didn't. So hang tight. I'm gonna find Arctic sea ice. Okay, my last show I think was, I can't remember. I have all these pictures. Let's just start from this is the 28th. I did a show about 7 days ago. Let's start with the 19th, and you can see the difference. So here it is, starting on the 19th, and this was thinning over here on the west side. Make that bigger, but not nearly as thin as it is today. So here we go with the 19th, 20th, and what you're going to see is it's a marked decline in the ice on this west side in the Arctic day by day. And you can see the hole that appeared there. That was on the 22nd. Look at that, just from the 22nd to the 23rd. Here's the 24th, and the hole is getting bigger, and you can see that that's really diminishing there. Here's the 25th, 26th, and that's definite melting there. 27th, and here's today the 28th. So that's from Climate Reanalyzer day by day, and we can also, we can come back. Well, let's go ahead, and I want to show you something else that's interesting. The jet stream. And this is, you can see the sea ice. This is overlaid over the sea ice for us here. So you can see the jet stream running right over that area that has had so much melting in this last week. And we can see the sea surface temperatures here, and over in that area it's above zero, It's about 5 degrees Celsius. Sea surface temperature anomaly. It's definitely warmer than normal, all up here in the sea surface there, and so that's just heating up all of that ice. We also have a lot of rain going on, and that's also in the same area that's melting so quickly up there, and then it's coming over. And we've had a cyclone up there chewing it up. There's a cyclone going on down here too, but we're specifically looking at the Arctic right now. Here's the 2-meter temperature anomaly. This is pretty much worldwide. And then here's the temperature from today, and it's actually close to freezing in parts over there that have already melted or are melting very quickly, but you know, it's fluctuating so much. And then there's an area, as soon as it goes into the green, it's above zero. So let's just go on the world tour here with the temperatures, and the heat waves are phenomenal. They're off the charts. And this is the average temperature we're looking at. We're not even looking at maximum and minimums. So this is all from today. Look at this stretch coming up from Baja up through California and Nevada and going up, and there's South America. Here's the South Pole. I want to show you something interesting. Look at Australia. It's really brown, so it's a lot hotter than it normally should be. New Zealand is also warmer. And see all this red in the Antarctic? They're in their winter time, and so their temperature, with it being abnormally high like that, it means that the glaciers are not as cold as they should be, and the sea ice in these areas are not going to be as cold. The ice isn't going to melt, isn't going to freeze the way it should. And so when it comes time for their spring, like in March, it's not going to be as frozen and as concentrated as it would be normally. And so they're going to have more melting next summer. That's my thoughts. So look at sweet Norway right there. That's like black. That's not, it's like right in here on the temperature. So now we're going to go to this Navy website, this new Navy website with the sea ice. First we'll look at the concentration. Here it is for today, and you can see that it's much less than we showed it a couple of days ago. On my Campfire Chat show we looked at this as well, and it's gone from red down to yellow just in 2 days. So yellow is between 60 and 70% concentration, and this is more orangey, red orangey, so that's more like 80% here, and then it goes on up to 90. And the only where it's really red is like right here, right above Canada, in those little nooks and crannies. And we can do this animation, and it'll run the last 30 days and do a 5-day forecast beyond. So it's going to August the 4th, and starting on September the 7th. So it's a 30-day, they say a 30-day. But look at the concentration that they're predicting by August the 4th. They're expecting the concentration to go way lower. And August 4th is only next week. That's coming up. And if I look at my calendar, I don't even know what August, it's a week from today. So if I do my climate cast update next Saturday, we'll see what it came down to. And now we're going to look at thickness. Here it is today. And zero, the white is 0, and the lavender is like right above 0, and this is in meters, and then this like medium purple is 0.5 meter, and so we're talking like this area is 0.5 meter thick. And then the blue starts at 1 meter. Then the aqua is around 2 meters. And there's very little of that. It's just right around the edge of Greenland, and then a little bit on the edges up here. So let's run this animation. And it goes to August 4th, and it starts on September 5th or 6th. I can't tell when they start. The 6th. So you can see the thinning of the sea ice as well. And once I found this Navy website and was able to look at this, I'm really going more with this than the other websites. I think it's more accurate. I think they've really got a pulse on what's going on. So you can see that by August the 4th, a lot of the sea ice will be gone or nearly down to 0. A lot of it. It's melting very quickly. And we've got 2 more months in the melt season. So we could have an ice-free Arctic. We really could. And now, here's the Arctic Sea Ice News and Analysis. And their data is a day old. So this is from the 27th. So this was yesterday. And you can see larger areas of holes in the concentration there. This is the North Pole. And you can see it's bluer. And so this corresponds with what we saw on the Navy site, but the Navy site I think is more accurate because it's showing 100% over here, and I don't believe that. I just don't believe that. So, and now I've got the NASA Worldview satellite of the North Pole pulled up, and this is from today. All their data is in, and we've got quite a bit of cloud cover, but there wasn't much cloud cover yesterday. Well, it's about the same. I mean, we can toggle back and forth and look, but here's Greenland, here's Svalbard, here's Novaya Zemlya, here's the Siberian coast, and here's Alaska. So we have to look through the clouds as we do this. And so we're zooming in to what we're looking at is trying to see the edge of the sea ice and the integrity of the ice. And what I mean by that is if it's broken up, if it's solid, if there's a lot of space in between the ice, you know, things like that. And what I'm really wanting to now, we can definitely see it's coming in. It does melt more on. It seems like it comes in more on the right side than the left, or the east side than the west side. It just is the way it's positioned, the way the ice is positioned and all of that up there. So, but the edge is right along here. That's the edge, and we can go back to Climate Reanalyzer, and it's a good way for us to look at that edge. I have to click and come back. You can see it's a pretty defined edge all the way up to this little island and where that juts out there, but then it's really like melting outward. And this is where that East Siberia ice shelf is, where the huge methane clathrates are stored. If we have time, I'm going to show you something else tonight too. It'll blow your mind. So let's look right up here, and we can see this is ice free right up here on that East Siberia ice shelf, definitely. And here's the edge, and here's the integrity. It's kind of webby looking, but then we've got some clouds that we're having to sort through. But you can see that the melting on the west side is coming up in past the 80 degrees north latitude. That's about 82.5, almost 83 degrees north latitude that we can see. And this is the thicker ice that we're looking at, and the older ice. And if you look back, now here it's breaking up a whole lot, and if you look back at the Navy view, and that's as much as I can zoom in on this one, we can see that this corresponds with our satellite view from NASA, that this is a little bit thicker. So this blue is about 1 meter going up to about 1.25 meters. And then it gets thicker right here in the middle. But the North Pole is here, so the thickest is not at the North Pole, it's to the left of the North Pole a little bit. It goes into the aqua, so that's about 2 meters thick here, and there's some thicker ice here and on this edge and then down here. So that's kind of how we need to judge these and look at it. But it is raining. You can see the clouds, and this is where the rain is happening. And so with rain, that ice is going to melt quickly. It's going to melt very quickly. So there's that. So let's go to the South Pole now and look at that real quick, because I want to show you ozone while we're here too. Here's our Navy thing, and now we're going to go to the Antarctic, and we can see their concentration. Well, it's a little less concentrated since a couple of days ago. Let's run. Look, see it's really fluctuating over here. That's the east side, and that's where they're having that high temperature anomaly over here. But the ozone hole has grown, and it's large over this whole east side. At least that's how it was yesterday. I haven't even looked at it today. So we'll look at it. And then let's look at the thickness. And we're interested because it's in their winter time down there, and the thickness should be building. And I looked on Wikipedia, and in the winter time, the thickness, it gets to be several meters, they said. and nobody really knows what the average thickness in the wintertime is, because this is salt water that has to freeze, and apparently pretty much all of the sea ice melts in the summertime in the Antarctic, and so they start out at ground zero. And they're going into their fall, they start out at ground zero, and so it has to start all over. And with it being salt water, it's harder to freeze than fresh water. It freezes, I think it freezes at a higher temperature. So we can see that it's coming along, but it's most of it is about 1/2 meter, and then the blue is 1 meter thick, and then a little bit is up in the 2 meter range right along up here and around some of the coastlines. But you can see, like over on this east coast, it's down to 0, so it tells me that there's something going on with the water that's coming into contact with the coastline so that it's not freezing. It could be glaciers that are running off, it could be temperature, it could be the water underneath is warm, it could be volcanic activity, because we have seen that there is volcanic activity. There's Mount Erebus down here that's constantly giving off sulfur dioxide. It's been active the whole time, 1,000,000 years or however long. And this is the Ross Ice Shelf here, and we can see that even right here there's white. So what's that about? If there's supposed to be an ice shelf there, wouldn't there be sea ice? I mean, what does that mean? I mean, I'm just thinking, these are just thoughts. I'm free-flowing. I don't know. I haven't looked at this before I turned on the recorder, and I said, let's just look at this and do a climate cast. So here's their animation for 30 days, and it goes to August 4th. So you can see that it's gradually growing. It is growing, but in my mind it needs to be growing bigger, bigger and faster and thicker in my mind. But I'm not a climate scientist, so, you know, what do I know? I'm just Margo. So, there's that. We'll go back to the Arctic in case we want to look at that. And you can see on this ice extent, the blue line is taking a nosedive. Now this dotted line was from 2012, and that's the lowest that it's been since they started like really recording it. And so we can see that in July the sea ice extent is taking a nosedive, and so it's almost down to the 2012, and it was below 2012 at the beginning of the season. We started out with less sea ice extent in March and April at the beginning of the melt season, quite a bit less, about millions of, I'm not a scientist, I can't read that, millions of square kilometers, I think that's what it means. So we started out with about 1,000,000 square kilometers less at the beginning of the year. And so now we're going to take another nosedive. That's in the Arctic for the extent. Here's the Antarctic, We can still see the holes. They're still showing up. Let's get a bigger picture. And we can still see holes. These, what one of my followers called dimples. But they are definite holes in the sea ice. So that's not completely solid down there. Uh-oh, I lost my thing. And here's the concentration. And you see it's quite blue over here. It's not very concentrated. It's quite blue. That's all on that east side. So, if we compare with the two temperature anomaly, this is flipped. And we actually have the air is warmer. You can see it on that east side where it's actually warmer. It's in the brown area. It's about 5 degrees Celsius, at least 5 degrees Celsius warmer coming off the coast and going on up. And so when we look, and there it is. So we can see the effects of these things right in front of our eyes. We can see that. So I've got cams pulled up, so let's move on over to cams. And before we look at methane, I want to look at ozone while I'm on the Antarctic. And I want to look at the South Pole first. There's the hole. That's on the east side, and it's flipped here. Here's that peninsula. This is the east side. That's from Friday. We have data from Saturday on ozone today. Let's see. It's there. The darker blue is not there. Let's run the forecast. We'll run that. And we can also load up ozone on our flat view here. And you can see the Arctic even is getting thinning ozone. The green, that color in the Arctic is about 275 DUs. They say 300 is average, but you have to have something higher than 300 to have an average of 300. So you can see, starting back on the 24th, which is what we have data back to, there was a hole of down to 200 Dobson units in the Antarctic. Of course, it is their winter time, and so the ozone is thinner over the cold area, thinner in the winter, and it should be growing back in the summer. So let's see what's going on over here. Here's our movie. Now we're running a forecast from today. It's coming back. They're forecasting it to come back even bigger by Wednesday. You see that? The purple. It's kind of a blue purple. That's 200 DU. And so that totally corresponds with this red area. And let's go back. And it's even moving out over the ocean. But no one talks about the thinning around the center of the earth, and it's very disturbing to me. Now we do have it thickening, really thickening up, going into the red and the black, which is good, but that doesn't mean that the ozone is coming back. That's not what it means. Okay, let's stop this movie. And now we'll run it worldwide here. And I'll move it around so you can see your part of the world. And I'm particularly interested in this hole that's right to the north of Australia, the blue, and then it's thinning down into mid-Australia quite sharply. But that seems to be a constant area over Indonesia and Papua New Guinea and the Indian Ocean, the Pacific Ocean, and northern Australia. That seems to be staying and not moving. And also over Ecuador, and we can see this 250 Dobson units is from about mid South America up to about the Panama Canal, and about the southern tip of Africa up to northern Africa. And then you have demarcations, and then the next level up is 275 DUs, which is this chartreuse green that covers much of the northern hemisphere. Much. And things that will eat up the ozone layer are sulfur dioxide, which is coming out of the volcanic activity going on, and another thing that will eat it up is chlorofluorocarbons, and also nuclear energy and nuclear testing. All the nuclear testing above ground blew holes in the ozone layer. And also the nuclear power stations use krypton 25 or something like that, and it's a radioactive material, and it disrupts it when it's used. It goes up in the atmosphere and disrupts the natural system for the Earth to replenish its ozone layer. So until we address the nuclear issue, and it's never going to happen, they're never going to get rid of nuclear. They never will. We're tied up with it. It's a bad contract that we made with nuclear energy, with nuclear weapons. It's a really bad contract we made with the devil. That's how I look at it, because those nuclear reactors have to be babysat. They have to be kept cool, and anyone saying that it's going to be the new clean energy, they're just full of shit. That's all there is to it. And they're being influenced by the dark mind. That's just my opinion, for what it's worth. Okay, while we're here, let's look at bad ozone, surface level ozone. We're going to run this, and you're going to see it quite high come up here in California because of the wildfires, You can see it up here in Alaska. It's over here in Siberia. See? Now, you're going to see it pop up. Okay, here it's popping up in California. There, you saw that? That's when that car fire, CARR fire started. It was a couple of days ago. And see, look at that bad ozone, how it's spreading. And there's so many fires around. It's incredible. And people are dying. The air quality is bad. Even, you know, it's blowing over to northern Nevada where I live. And I'm having to keep my windows closed. I did go out briefly for a little while yesterday, and the wind had blown it out enough so I didn't react too bad. But I've had my windows closed all day today and the air conditioner on. So let's zoom in and take a look at some of these hot spots. Literally hot spots. Okay. And I'm not sure what's going on in Alaska for the ozone, bad ozone, to be coming up there. I'm not sure. If anybody knows, let me know. I don't know if there's a fire or if that's the edge of the Yukon. If anyone has any idea, if they could just leave it in the comments, that'd be great. Okay, here we go. Now watch. There it is. That's the fire, and you can see where it's spreading, and even at night it's still being picked up because the fires don't go away. And now we're into forecast period. So, and Greenland is still green with the ozone. I don't know why. No one's given me a good explanation for that. We have it coming off the coast of Asia on the right there. I don't know if that's still wildfires up in Siberia still, or what's going on. I really don't know. I'm not following all of that. Get New Zealand up there. New Zealand, you're looking okay. Well, they would crash it. Well, let me get it back. That's okay. I think I'm done with bad ozone. So, let's go to methane. I appreciate all the kind comments that people leave. Okay, that's the South Pole, because that's where we were at. This is total surface. It defaults to total column. And this blue is about 1680 parts per billion. And then, so we're not really worried about methane coming up right now down there. Although I did see in the big Guy McPherson paper that he wrote, that's on his website, I did see where it's suggested, I don't know for sure, it's suggested that there is methane stored in the Antarctic under the sea ice as well. So I don't know. I I don't have the data on that, so I don't know. So we've got actually 4 days of data here for methane, including yesterday. And this is, we're still on total column. Hi, I'm back. They crashed my computer. So, in fact, it crashed several times in between when they crashed it, and now I'm back. So, we're back on cams looking at methane. And this is from the North Pole, and this is total column level. And like I was saying, I've never seen it this bad at total column level before. And I also have it pulled up, the flat view, and let's look at the plots view here. And total column is the measurement from the methane from the ground all the way up through the atmosphere. So it's the total measurement in the column, and it's way up high, it's up about 2,300 parts per billion right over here in India. And then the other red is not quite 1,900 parts per billion. It's like 1880. And then orange, that brick, this dark orange is 1860 parts per billion, this color. And then the lighter orange is 1840, that color. And then this is 1820, that yellowy color. And then this chartreuse is 1,800 parts per billion. So that's total column. And so when we switch to surface level, I like to do most of the things on surface level. There's that world view, and let's go to surface level over here, looking down at the Arctic. And I like this view because we can see the whole northern hemisphere and part of the southern hemisphere, and we can also see the methane going into the Arctic. So we're going to let that load. The base time, let's go back to the 24th, and we'll run the whole movie, and then it'll run into the forecast period. It'll run through today. And so we have actual data through the 27th, and so the only forecast period is today. So we're going to let that load, and while that's loading, we're going to come over here and load up this one and let it run. It runs faster. And I'll move the map around so you can see your area. And I'm not going to go into a lot of explanation about cams and stuff on these videos now, because on my earlier videos I did. So you can go back to some of my earlier ones where I go into detail about reading the graphs and what it means, and about methane and stuff like that. So what we're looking at is the data here, and we're looking at all of the methane in Norway and Sweden and Finland, and just it's like black just coming up and coming out of the Arctic, and here up by Novaya Zemlya, and it's just this whole black area. And so this is heating up the atmosphere even more, and we can see it over here too. Let's zoom in on the United States and look at the methane areas as it runs through. I may have to reload it since I zoomed in. Okay, it's loading up. So we're in serious trouble, people. We're in serious trouble, and you know, the climate scientists know, and some of them are willing to say how serious it is, and anyone giving prescriptions and solutions are not looking at the big picture. And like I said in the campfire chats on Thursday, you know, I read the beginning of that Bloomberg article that talked about how the rivers in France are too warm to even cool the nuclear reactors. So what does that mean? The water can't cool the nuclear reactors. Well, they've got to shut them down, and they've got to take them offline, but they've got to cool them somehow. If they don't cool them, they're going to start melting down. Now look at the methane coming off of the east coast of the United States here. Hi, I'm back. They crashed my computer again. I'm hoping I can finish up this climate cast in the next sitting before they crash me again. So we have methane in the Arctic loading up, and I was showing it to you on the flat view and showing the methane coming up, and it does grow bigger and bigger and bigger through California, and we've got a big plume up here in Canada and all over northern United States. Then we had a whole bunch coming off the east coast, and we've got this in northern South America and stuff in southern South America. And it's not moving, this is just the frozen screen, and we can see that Europe is covered up in dark methane, Norway, Sweden, Finland, and then northern Russia here, and big pockets of this dark methane. And here it is coming up by Novaya Zemlya and all in the Arctic Ocean there. And here's Russia, and then it's yellow above the Arctic Ocean there, and then northern India, and then China again as usual. So there you have it. And let's see if this is running now. Here we go. So there it is from the top down, the top view of the world. And you see it's yellow. It's coming up yellow in over here by Alaska, and we saw that that's where the Arctic sea ice is melting very quickly. This whole area, see, it was yellow all over here, and so that's it was like at the yellow orange 920 and 940 parts, I mean 1920 and 1940 parts per billion even. So there's that, and I'm going to close that one out, and we're going to look at, well, we're going to look at sulfur dioxide last, because I have some brand new information that I found. This is thanks to Sultan Bev, one of my YouTube subscribers, emailed me with this link to government website. This is the U.S. Department of Energy government website, and I've got two pages up. One is the Office of Fossil Energy, Science and Innovation, and this talks all about methane hydrates, and it talks about the types of methane hydrate deposits, where they're located, here it is. Here's like the frozen ground, and here it would be in the permafrost down here. Here's the water, like the ocean, and there are deposits in the ocean, and even way deep. Hi, it's Margo. I'm back again, and they crashed my computer yet again. So this is proof to me that this information is being suppressed and they don't want it out there. I mean, the computer just keeps crashing over and over and over again. So this is about methane hydrates. It's from the Department of Energy's website, and types of methane hydrate deposits. And it says that the depths that go down greater than minus 460 meters, and the sediments perhaps minus 7 kilometers deep. And they had plans on drilling for this. And here's ocean deposits, impermeable solid hydrate embedded in sediment and trapped methane gas. And then they even show slow seepage of thermogenic methane gas from below that's coming out of the sea floor. So I'm going to leave links below to these websites, and it talks all about it. I'm afraid they're going to crash my computer again before I can really go over this with everyone. But this is very, very important, and they have plans on making lemonade out of lemons. Basically, you can just count on the government or the powers that be making lemonade out of lemons. If you've got methane, well, by God, you know, they're just gonna tap it. They're just gonna use it somehow. And it's the stupidest thing I've ever heard of. It is absolutely the most insane plan, the stupidest thing I've ever heard of. Now, here's another website. This is from energy.gov. This one was energy.gov too, but this was a different link. Office of Oil and Gas Hydrates. But what I want to highlight is, once thought to be rare, gas hydrates are now believed to occur in vast volumes and to include 250,000 to 200,000 trillion cubic feet of methane. I don't know what that number means, but I've never heard of that. And I don't know what area they're talking about, whether it's a certain area or worldwide or under the ocean or in the ground or under the permafrost or what. But let me read that again. Once thought to be rare, gas hydrates are now believed to occur in vast volumes and to include 250,000 to 700,000 trillion cubic feet of methane. This large store of organic carbon raises a wide range of science and technology issues, including gas hydrates' role in global carbon cycling, natural geohazards, and as a potential future source of energy. They had big plans. Investments by the U.S. Department of Energy's Office of Fossil Energy through the National Energy Technology Laboratory, along with collaborations with academia, industry, states, and international partners, have led to substantial progress in addressing these issues through scientific drilling and sampling programs, numerical simulation, and laboratory experimentation. They found, okay, and I'm going to back up, gas hydrates consist of molecules of natural gas, most commonly methane, enclosed within a solid lattice of water molecules. Gas hydrate deposits are found wherever methane occurs in the presence of water under elevated pressure and at relatively low temperature, such as beneath permafrost or in shallow sediments along deep water continental margins. And then they have this excellent picture here that's too small to read, and I can't download it. See, it's just part of the PDF file, but I can blow it up. And so we're going to look at this. Now this shows, now here's permafrost, and it's climate sensitive down to this line. So that means like with the warming and the melting and everything. And so they're targeting methane deposits below the permafrost that's not coming up immediately. That's so they can control the release of it, I'm thinking, just from what I've skimmed through. I haven't really read these documents, but these are the targets. Okay, and then this is climate sensitive. They've got a whole line. Here's the ocean level. This is 350 to 600 meters underwater, and these little bubbles that symbolizes methane bubbling up. And then this is biogenic gas generation. It starts right here. The gas generation starts here. And then okay, like A is hydrate bearing marine clays in massive forms, A and B. So this is the bottom of the ocean. They're looking at the bottom of the ocean. They're going to be drilling down into the core, into the earth there, just like drilling for oil, just like oil rigs off the coast of the Gulf or Alaska or anywhere else. And maybe they've already been doing it and we don't even know about it. How about that? How do we know that some of these offshore oil rigs aren't already getting these methane hydrates and they're learning how to process them? That would not surprise me at all. Okay, C is hydrate bearing marine sand. So sand, that's the bottom of the ocean. D is seafloor mounds. Where's D? D is the seafloor. So all of this is under the seafloor. E is hydrate bearing clays finely dispersed. And F is hydrate bearing Arctic sands. So you can see that those are a lot easier to get to. They're not as far down. And they don't have to go through the water. That's from the land, the permafrost. So, I thought you would be interested in my new find, and they're doing all kinds of research on methane hydrates and how to go in and tap into this and make lemonade out of lemons. They want methane to come up. I think they want global warming, and I absolutely think that they want the Arctic sea ice to melt because they've got big plans for developing all of that too. I found a whole huge document about that. That's another show. But they're working on it. They're totally working on it. So there's that. I'm going to leave the links below. And now we're going to close out with sulfur dioxide if my computer doesn't crash. I've been saying prayers. My friend is on the phone praying this whole time so that my computer will stay up so I can finish this show and get the message out. This is power to the truth. We are being lied to. This information has been suppressed. We don't have any clue what's going on right under our noses. Right under our noses, people. We don't have any idea. And it's the dark side, it's the dark mind, it's Satan. It's all clouding people's vision, clouding their perception, clouding their thought processes. There are no fixes. There's no fix to this, because the system is evil and the system is run by Satan. This is not our world. It never was our world. It's being run by a dark, evil presence, and no matter what you do to try and change it or help it, if you don't play their game, if you don't run by their rules, you'll get taken down, and your efforts will be null and void. There's no way out except spiritually. So, my name is Margo. Time is short, folks. Time is very short. I recommend you get your spiritual houses in order. Get right with God and Jesus. That's the only way. I love you all, and until next time, God bless you. Go in peace and power to the truth. And Jesus said, I am the truth, the light, and the way. If you want to know the truth, then you have to be open to it, whatever it is. And we're living in hell. This is hell, and I can't wait to get out of here. And whoever's ready to go, I'll help you get ready. So, God bless you. I love you. Good night.